Come on in, everybody. There you go. Get your cameras on for those of you that don't yet. I was just looking at the grades in Buzz, and there's a few of you that have not even logged into anything in Buzz. I mean, you have not gone and looked at a lesson. You've not looked at an assignment or anything. I see one, two, three, four, at least five people, which means your grade ain't doing real well either. There'll be a lot of people going to be here on asynchronous days. This keeps up. Of course, we had the serial assignment a week ago, but the first assignment from the curriculum, which was, let's see, what was it? Introduction to something here. Intro to programming was due Sunday night at midnight. You don't know your username or password. Your username is your email, except don't put at BittonvilleK12.org. Leave that off. Don't put that. Anybody else still struggling to even figure out how to get online? And then, of course, the first thing you have to do when you get online is that academic integrity. And after you hit submit at the bottom, before you leave, you have to hit that mark this activity complete button, or you'll still be stuck. So any of you folks that haven't marked this activity complete, haven't hit that button, see if I can pull it up on screen and show you what it looks like for those of you that are missing that. And you folks that got to the end of the first week's assignment and couldn't log on should at least send me an email and say, Mr. Brock, I'm having trouble logging on. You got to communicate with me. Okay, there's this button. It looks gray on my screen now because I've already clicked it. But right here, there's a submit right there. But to the left of that, mark this activity complete. You have to click that button as well. Submit and that on the academic integrity contract. So if you don't click that, Buzz will still hold you up. It won't let you look at anything. And you'll be like, wait, I'm trying to do an assignment. I can't go see it. Right, because you have to click that, mark this activity complete. All right. Let's see how many folks we got in here. Almost everybody. Well, not almost everybody. This is a big class. We got like 25 people in this. But let's get to our lesson for the week. Yeah, you guys can't log in, communicate with me. I don't know what's going on your end. Unless you guys let me know. All right, so looking at our Buzz class, if we go to the grade screen, that's the best place to start your week there. Start your week on the grade screen so you can see what assignments we've had, see what you've turned in, see if it's been graded, and see what's coming up. So we can see in August, we had these two assignments, the Let's Have Cereal, which I also had in the Google form at first. Now it's only in Buzz. And Intro to Programming. That was last week's assignment. It was 5 questions, multiple choice. If you haven't done it, you can still go back and get it done. It's not too late. It is past due, but it's not too late. This week, we just have September 7th, Introduction to Python. Next week, we'll be writing our first program. We'll be writing our first program next week and turning that in. But this week, we just have 1.02. So let's go back to the activity screen. And let's look at the 1.02 Intro to Python lesson. See what it's trying to teach us. Now, you got to pay attention. There's lots of little details in there. It's going to be on it's a multiple choice quiz again at the end of this. And it's going to be about what we're reading here in our lesson this week. Speak, listen, and respond. See, that's in the human world, we call that communication. You speak, you listen, you respond. We use our common language, whether it's English or Spanish or hand gestures or shouty capitals or emojis, however you communicate, but we communicate with one another, and computers are not so different. Just as people use human languages to communicate with each other, programmers use programming languages to talk to computers. So we're going to learn to identify the characteristics of low and high level programming languages, identify programming languages and their uses, and explain the differences in compiled and interpreted languages. Input simple Python statements. So let's go to page 2. All right, programming languages. Computers are really great at taking orders, but it involves a bit more than you just tell them what you want to do. Hey, computer, can you just print out a program that does this? Luckily, your computer will obey commands a lot more than your little sister or brother. Yeah. The key is using a language computers can understand. They're called programming languages. That's a language used to write instructions that can be executed by a computer. So there's two types of languages. There's high level and low level. And there are thousands of programming languages, and every one of them falls into one of those categories. They're either low level or high level. In the early days, a programmer's only option was to use low level languages, also known as machine code. It's a set of instructions with ones and zeros. Everything was in binary. That's how everyone had to communicate with computers, write binary programs. And as programmers made advancements in their industry, they created more human-friendly programming languages. Today, we call those high-level languages. These high-level languages can translate human messages into machine code that computer can understand. Right? Like just putting the word print is a high-level language, because print doesn't mean anything to the computer, but once it translates it to zeros and ones and tells it what print means, it knows what to do. All right, let's look. On the left is low level. On the right is high level. Let's look at the description of those. Low level is considered less readable by humans because they're written in the computer's native machine code. If we put this program in front of you, you'd have no idea what it does. You wouldn't be able to read it because it's written in zeros and ones. It's in binary. On the right, much closer to human languages than low-level languages, high level makes it easier for us to learn and use. We could have a chance of understanding this program. If we know that programming language, we can read through that code and know what it's going to do. Where these zeros and ones, no idea. Uses. Low level is used to write code, write instructions, write programs that control the computer's hardware. High level is to write programs for just about anything. You could create an operating system like Windows 11, complicated scientific calculations, general applications like creating a word processor. Someone created Microsoft Word. Let's look at the pros of each. With low level, a pro is more control over the hardware, and it's faster. Execute tasks a lot more quickly because it's already in the computer's language. It can just read it and go. Over here, high level, the pros are it's more user-friendly because we can actually understand by looking at the code and can be used on different kinds of hardware. Let's look at the cons. The cons over here on the left is easy. Low level is written in machine code. It's just challenging to understand. You'd have to translate all of that zeros and ones into something we have a chance of understanding. High level, when it runs, programs are slower than ones written in low level because it has to translate everything to low level and then run it. If it's already low level, it's already zeros and ones, you can just take off with it. But if it has to be changed into zeros and ones, that has to happen before the computer knows what to do. What are the limits of each? Low level, programs are written for specific computers, and they'll only work on that one type of computer. High level must be translated into machine code. That's a con. That's a limit. Got to be translated into machine code, and this is done by interpreting and compiling, which we'll talk a little bit about more. Page 3. Interpreted and compiling. See, I said we was going to talk more about that. Let's talk about high-level languages, because that's what we really care about. We don't want to learn binary. They're complex, and to understand them, computers need something to translate that into machine code. This is where interpreters and compilers come in handy. So both interpreters and compilers, they can translate a high-level language for a computer to understand. They have similar functions. They just do it a little differently. Let's talk about how they do this. Interpreted language, okay? Interpreter compared to a compiler. An interpreter translates one line of code and then executes that before moving to the next line. So it'll take the first line, change it to zeros and ones, send it to the computer, and the computer will do that. Then it looks at the second line, converts that to ones and zeros, sends it to the computer executes. Then the third line, and so on and so on and so on. That's how an interpreter does it. It's going to interpret. Think of it as someone giving a speech and you have an interpreter. Generally, they say a little bit of their speech, and then the interpreter goes in and interprets that and gives it to the audience. And then they say another part of their speech, and they interpret it and give it to the audience. Another part of the speech, and one line at a time, basically. It's like an online language translator. You put a single phrase in, and out pops the same phrase in French or Portuguese. You know, you can go to that Google Translate and enter a sentence at a time. Python is an example of an interpreted language. When we write programs, Python's going to execute it one line at a time. It's going to convert that and send it to the computer. So here's an example. Follow these instructions step by step to find the hidden epic relic loot. Okay, you're playing this game and you want to find this magic chest here. Walk to the end of the hallway. So on your game controller, you press forward until you walk into the hallway. When you get in the hallway, then you turn left. So you'll turn left on your controller. Then you walk to the end of the hallway again. So you're pressing forward. Then you turn right. And then you open the treasure chest. So you click on it and open it up. That's a step-by-step interpreter type way of doing that. You do one thing, then you do the next thing, then you do the next thing, then you do the next thing. So here you're following one line of instruction at a time. This is what an interpreter does when it translates high-level languages to machine code computers can understand. So here's some quick facts about interpreted language. To run a program, interpreter software is required. And for others to run the program, they must have the original source code. That's a program written in high-level language. They got to have the original Python program, right? Programs written with interpreted languages tend to run more slowly than those of compiled languages. All right, let's compare an interpreted to compiled. So a compiler translates all lines of codes together and executes them all at once. So think of it, that guy giving a speech, the interpreter's over on the side. So he listens to the whole speech and then he turns around and says the whole speech in English. He compiles it and says, okay, this is what he said. And so then they tell you, okay, he just said do this and this and this and this and this and this. Instead of doing it one line at a time and interrupting him, waits to the end. So this is more like translating an entire book into a different language, right? You can do it page by page, line by line, or the whole book at one time. You wouldn't do just part of it. You translate the whole thing and release it all at once. Java is an example of a compiled language. So here's an example in there. Follow these instructions to the hidden epic relic loot. It says walk to the hallway, turn left, walk to the hallway, turn right, open the chest. So you read all the directions first, and then you go forward, left, forward, right, open. But you got all of the instructions at the very beginning. You didn't do it one at a time. Go into the hallway. Okay, I'll do that. Okay, now what? No. You do it all. You get all the instructions at one time, and then you do it. In this example, you're reading the complete set of instructions and then carrying them out all at once. This is what a compiler does when it translates high-level languages to the machine code that computers can understand. So here's some quick facts about compiled language. A compiled language produces translated machine code that can be saved and run later. The compiled program can be shared with others while keeping the source code private. You don't have to know line by line by line by line. The compiled code is ready to be executed, which we also call running the program. Compiled programs tend to run faster than interpreted language. It's faster to read all the directions and do it all at once than to do one line at a time. So here are some of the most common computer languages and what type of language they are. So Python. All right, here's the quick facts on Python. It's a general purpose programming language developed in 1991, so it's not that old of a language, by Guido van Rossum. Guido van Rossum is the creator of the Python programming language. It is often used as the first language to learn, as we're doing here. It's used for web applications, software development, and it's used by Google, Yahoo, and YouTube. They all use Python. It is a interpreted high-level language. Interpreted one line at a time, high level, because we can read it. Java. Let's compare that to Java. It's a popular programming language named for the amount of coffee that the programmers drank while developing the language in 1995. That's how they named Java. Because when they were writing this new program, they drank so much coffee, they said, let's just call it Java, because Java is how we got here. It's used in web applications, network programming, Android devices, etc. It is a compiled language, and it's a high-level language. So it kind of looks at everything at once and then executes it. Let's look at C. This is the name for the 1972 language, came from an earlier language called B. So basically they had a language called B and then they improved it and wrote a new language. So they just called it C. Just next thing in the list. Like, it is the second most popular programming language, and it is used in computer game development and cross-platform programming and more. So it is a compiled high-level language, just like Java. Now let's look at assembly language. This uses letters and numbers to represent machine language. It's nothing you could read. It is a low-level language. Machine language. This uses ones and zeros to communicate with the computer. It's very hard for us to understand and write. It is a low-level language. It does not use words, ones and zeros. HTML. This is a markup language. It's not a programming language. You don't program anything in HTML, but it's used to present stuff like websites are HTML. Rendering agent displays code, sometimes all at once like a compiled language, sometimes one line at a time. So it's a markup language. It's not interpreted or compiled because it's not a programming language. And it is a high-level language because we can read stuff in HTML. All right, let's look at page 4. Programming, start here. So in this course, you will begin your programming journey by learning Python. Information technology, what we call IT, careers, can be found in nearly every industry, and different programming languages meet different needs. So job seekers got to be able to show flexibility. So because of this, if you decide to have a career in IT, you'll likely need to learn more than one programming language. But the good news is, once you learn one language, learning another language is much easier, and you'll be more marketable as a programmer the more you know. Python is an excellent place to start because you can quickly pick up and understand. We can learn a lot this year. Python will teach you to think like a programmer, which will help you learn other languages. It also provides foundational programming principles. It allows you to develop good design habits and how to troubleshoot issues. These skills will make it even easier to jump into new languages later on. But don't get the idea that Python is too simple to be useful. I mean, Google, NASA, the New York Stock Exchange, all these big businesses use Python for advanced applications. So it can do a lot. Here, while we talk about programming spotlight, is Guido van Rossum. He's still alive. He was born in 1956. He was the class clown. He's a Dutch programmer, and he wrote Python and earns the title class clown. He was a big fan of the Monty Python comedy group. Big fan of that. He's aptly named his program after them. Python is named after the Monty Python British comedy troupe. Python users have nicknamed him. He is called the benevolent dictator for life, because since he founded the code of Python, he still has the final say in all Python disputes. If there's some questions about how some code is supposed to be used, and there's arguments about different ways on how this code is supposed to be used, he's the one that gets to settle the argument because he created Python. So he is called the benevolent dictator for life because he's got the final say. He said so, so it is. All right, page 5. Let's program. So in this course, you have access to the Python idle tool. Just to remind you, it's right here in the menu, idle. When we click on that, it opens up this programming window. Takes it a second to load usually, but yeah, we write code right here. This is where our code goes, right in the top half of this window. And when we run it, it displays what the program does down in the output at the bottom. So that's what we're using. This handy tool lets you do just about everything. Write, run, debug programs written in Python. The idle is your Python programming environment for this course, and it's an easy way for you to practice programming while you work. The idle checks everything you type, including punctuation, typos, and keywords. And when you get an error message, don't worry, making mistakes is part of how we learn a program. I still make errors when I write programs. That's the life of a programmer, is you're going to run into errors. It's just a matter of finding them and fixing them. So step 1, open Python idle right there. Okay, so we've done that. We've got our Python idle window. It says Python idle will appear. Here's a picture of it. You should see the code window on the top. Let's try some Python code. So in the code editing window, type the following exactly as shown. All right, so you guys are free to do this. You have access to this. We're on page 5 of our lesson. It says type, print, parentheses, here we go, exclamation mark, close your quote, close your parentheses. Hit the run program. There it is. Output. Here we go. It says, congrats, you just gave the computer your first command. So you can open up this idle window. I always recommend you go back and go through these little practice versions with your computer. Now, under the first print statement, let's type a second one. Okay, hit enter, print, parentheses, quote, Python is a language and a reptile, exclamation, quote, parentheses. Run again. Oh, now it's here we go. Python is a language and a reptile. It says Python can do math too. So the output is impact. So let's see if we type this and run, hit enter again, print 10 plus 16. Let's run that. Oh, look at our output. It didn't print 10 plus 16. It printed 26. And then it wants us to try another one, print another parentheses, 24 divided by 6, close the parentheses, times 20, close parentheses again. So it should divide 24 by 6 and then multiply the result times 20, and it gets 80 right there. Very nice. So it should look like this. Ours went ahead and gave it a 0.00, but that's still 80. That's it. So that is the end of this week's lesson. Like I said, next week, we're actually going to have a lesson that you have to turn in. You got to write a program and turn it in. Let's look at the assignment that goes with this week's. We just did the Introduction to Python lesson. So now let's do the Introduction to Python assignment. Get here and click Start. In what way are low-level programming languages limited? For what purpose are high-level programming languages used? What's one difference between low and high-level programming languages? Which of the following is a programming language that translates code one line at a time? Which one of those? What is the purpose of interpreting and compiling high-level programming languages? All right, 5 questions. 5 questions. It's all about what we read. You got 3 attempts, so if you don't do well the first time, you can try again. It'll probably give you some different questions the second time. It doesn't give you the same 5 questions. Your questions may be different than what I just looked at. So you may have different questions than what I should have there. So you've probably got, well, you got plenty of time because we just do 45-minute classes, and then I'm going to be programming 2 in here in about 10 minutes. So you guys have time to go in there and try that little programming exercise. Go to that page 5 and try the little programming exercise and get those 5 questions done. And you can go back, you can save and exit and go back. It's like, oh, I don't remember which one of these was a low level, which one is high level. You hit save, go back to the lesson, look at that page that compared all those lessons, Java and Python and C and assembler language and all that. And, you know, look at that again and go, oh, now I know the answer. Then go back and it'll let you pick up right where you left off, as long as you hit save and exit when you do that. So, all right, I'm going to let you guys go get started on this assignment. If anyone's still having trouble in Buzz, hang around. I got a few minutes before programming 2 starts, and let's make sure and get you fixed up to make sure you can get the work done. We'll make sure you can get the work done. But otherwise, if you're good to go, you can get into Buzz, you can get to the assignments. Go for it.
What? Just ride. I just need a ride. I just wanted a little ride. That's all I needed. Come on, Big D. Come on. What is it? What?
Painting.
I just wanted to go to a wedding. That's all I wanted to do.